This is the third video concerning tests of the mean, hypothesis tests of the mean. And we're going to look at the third problem and work our way entirely through that. So let's get to the problem. And we have that we have a random sample of 41 introductory statistics classes at Big Ten universities, and it has a mean of a mean class size of 33.25 with a standard deviation of 6. At the 0.05, alpha equals 0.05 level, test the claim that the mean class size is less than 35. Okay, so I've highlighted in yellow the claim information with the significance level 0.05. The claim says that the mean is less than 35. So that's pretty straightforward. And the sample information is we got a sample size of 41, we've got a sample mean of 33.25, and a sample standard deviation of 6. And so we look at we set up our claim and our alternate hypotheses. The claim does not include equality, so the alternate is the same as the claim. And we see it is a left-tailed test, one tail. And with the test statistic, again, because it's a test of the mean, we're dealing with a t test statistic, which requires our sample mean, which is 33.25. Our assumed value of the population mean parameter is 35 from H0. Sample standard deviation was 6, and a sample size was 41. Put that into the formula for test statistic, and we get negative 1.868. And we need to determine now if negative 1.868 is an unlikely value based on the assumption being true. So that's what we're going to do in step 3, and we're going to use the critical value approach, and we're also going to look at the p-value approach. So the critical value approach, just as in the other two, we're going to use table A3. This is a left-tailed test, so what we're going to end up doing is looking for alpha in the area in one tail. We're going to then go down that column that alpha is at the head of, and we'll stop at the degrees of freedom row. In this case, it's going to be 40, n minus 1, 41 minus 1. And then it's going to give us a value, and since this is a left-tailed test, remember the table only gives us right-tailed values. We're just going to change the sign for the left-tail value. So we'll find the test statistic critical value and change the sign in this case for a left-tailed test. So let's just take a quick peek at the table, and we'll work our way down through that. Again, left-tailed test, so we're at area in one tail. Alpha was 0.05, so we're in the 0.05 column. And so we're going to go down then to the 40 degrees of freedom row, because T is identified by its degrees of freedom. And we get 1.684. That is a positive critical value. We need the negative because it's less than, and we just change the sign to negative 1.684. Okay, so let's go back up to the problem, and we're in problem 3. And so our test statistic, our critical value is negative 1.684. And remember what we do with critical values, the rejection region for a left-tailed test is to the left of the critical value, is the test statistic farther to the left of the critical value than, farther from the mean on the left side than the critical value. And indeed it is. Negative 1.868 is farther from the mean than negative 1.684. Therefore, it is unlikely to occur under the null hypothesis being true. Okay, and then let's look at the next thing in step 3, and that is the p-value. And remember, you can use one or the other. You don't have to use both unless you're specifically asked for one of them. And a p-value approach, again, it's finding a probability, it's finding the area underneath the curve farther away from the mean than the test statistic. And our test statistic is on the left, so we're going to find the area underneath the curve farther to the left of negative 1.8, farther to the left, farther from the mean than negative 1.868. Okay, so, and again, this is the tcdf function, and it requires that we have a lower bound and an upper bound. And if we're looking on the left side, where the lower bound is going to be a large negative t-value, and the upper bound is going to be the test statistic value. And you should just basically remember these things right here. You take some time to familiarize yourself with the how you're going to use the tcdf function here. Okay, so let's go look at the tcdf function on the calculator. And again, the CDF function it's a probability function. So we're going to do second, vars, and number 6 in this case. And by the way, if you have a TI 83 plus, then it'll be number 5. It's the 5th function in that list. So TCDF. And now we need 3 things. We need the lower bound value, the upper bound value, and again, the degrees of freedom, because the T is defined by its degrees of freedom. And so we're going to use a large negative number. So negative 9999, comma, test statistic, negative 1.868. As I recall. Oops. 868, yes. And then comma, and the degrees of freedom, which in this case is going to be 40. Sample size -1, close parenthesis, and we get a p-value. Probable the area underneath the curve farther away from the test statistic than the farther away from the test statistic, or from the mean than the test statistic, and it's 0.0346, rounded to 4 decimal places. So let's go back to our document. And we compare the p-value to alpha. And remember, we will only reject in the p-value approach if the p-value is less than or equal to alpha. If it's greater than alpha, we will fail to reject. And our p-value is smaller than 0.05. Therefore, we will end up rejecting. So in our decision, we would say that we're rejecting 8.0, and because the p-value 0.0346 is less than alpha, which is 0.05, or we would say, if we're using the critical value approach, that the test statistic negative 1.868 is farther from the mean than, there's an error in here, it should be negative 1.684. The test statistic, negative 1.868, is less than negative 1.684. Therefore, we'll reject 8.0. I'm going to have to go back in and fix that. All right, so when you look at the document again, it probably will be correct. And then we state our conclusion using the flow chart from in step 5 from the formulas and tables handout. And finally, we'll go in and run the hypothesis test of the mean using this information Remember that is stat, right arrow to tests, and hit number 2. So let's go ahead and run the test. We need to know what the sample information is. We need to know what the null hypothesis value is. And we need to know what the relationship is in H1. So let's go back to the calculator. And let me clear that out. And remember, the test for test of the mean is stat, right arrow to tests, and it's number 2. And we're going to go down to the mu0 was, right? Mu0 was 35. And X bar was 33.25. And the standard deviation was 6, and the sample size was 41. And the alternate hypothesis was less than, and then we hit calculate. Actually, let's go down to draw again so we can see the p-value sketch. And we hit enter. And there's our left tail. And it gives us the 2 important pieces of information, the test statistic, -1.868, and the p-value 0.0346, which we would use then to make our decision. Remember, the test that only gives us the step 3 p-value, does not give us any information on critical values. And that concludes the 3rd hypothesis test of the mean. And we'll do some different tests where we have a hypothesis test that has been calculated for us, and we only have to come up with the statement of our conclusion, and I'm sorry, the decision and our statement of conclusion. So let's we'll end this video with that.